Okay, today we're going to start talking about lesson 813, which is stretch factors of polynomial functions. The first thing I want you to do is to pause the video so that you can write equations of these three graphs. It is 8-45 from your text. Pay attention to the orientation of the graph. Pay attention to the zeros of the graph. Remember, zeros are another name for x-intercepts or solutions. And also pay attention to if there are bounces or lounges. Okay, go ahead and pause the video, write three possible equations for this. Okay, at this point, you should have already written these equations in red. These are for the first two. We have y equals x because it goes through 0, 0. X plus 3 matches up with negative 3. X minus 2 matches up here. Positive orientation, so it's positive. The second one is a negative orientation, so we have a negative. It does a lounge right through 0, 0, so x cubed. It goes through negative 3, and it goes through positive 2. So you should have that. Now, what I have here in green is what the new concept is today. And the new concept is saying we have been writing possible graphs, and today our goal is to write an exact equation for our graphs. So in this case, you probably didn't notice this, and that's okay, but in part A, they actually gave you an ordered pair other than just the x-intercepts at negative 2, 8. And we know that negative 2 represents x and 8 represents y. So if I plug in 8 for y, and I plug in negative 2 every time I see an x, I can see, is my equation correct or not? Okay, so I'm going to leave that 8 alone. It's negative 2 times positive 1 times negative 4. And if I multiply the right side out, negative 2 times 1 times negative 4. I do get 8. That is correct. That tells me this equation is correct, and I don't need to do anything different with it. This bottom one didn't really give you a very clear extra ordered pair, so we're just going to skip it. If you have this, you are good to go for part B. In part C of the same question, okay, you should have what's in red. You should have a negative, you should have an x plus 2 squared, you should have an x minus 1. And maybe you noticed, maybe you didn't, but the y-intercept that they gave you was 8, which represents 0, 8. So 0 gets plugged in for every x, 8 gets plugged in for the y, and let's see what happens. Okay, let's leave the 8 alone. I have a negative there. 0 plus 2 is 2. 2 squared is 4. 0 times negative 1 is negative 1. If I multiply the right side out, I get a positive 4. But those are not equal. That means I don't fully have the equation. Now, that doesn't mean you've been doing it wrong all week, or if you got this, it doesn't mean you're far off. Let's think for a second about number 46. What's the difference between these two equations? You guys should very quickly see they both have an x-intercept at negative 1, positive 3. They both bounce at 0, and the difference is there's a stretch factor. The second equation has a vertical stretch factor of 3 as compared to the first one. So let's use that and think about it. We're kind of thinking, well, what could we have multiplied by here? So 4 times what will give us 8? Okay, this is a nice and easy one. 2 is really the a value, so I can put a 2 in here. Now, let's check and see what happened here. 0, 0, that's negative. Yeah, we're going to talk about the negative and the 2 later. But this equation now, y equals negative 2 times the quantity x plus 2 squared times x minus 1 is the correct exact equation that matches up with this. So one new step today. That's it. So here's number 47. We already talked about 46. And they have this w equation. It crosses at negative 3, negative 1, and it bounces at 2. So they've already given you the base equation. X plus 3, x plus 1, and x minus 2 squared. Our job, though, is to figure out the exact equation by finding what a is. We've done this earlier in the year with parabolas, figuring out what the stretch factor is. So in number 47 in the book, they do give you, as part of the instructions, that the ordered pair 116 is a point on this graph. So, of course, 1 represents x, 16 represents y. So I'm going to put 16 equals some a value. And we're just going to write a. Even if we saw that this was a negative orientation, we're just going to put an a value here. Okay? And then we do x, which is 1. So 1 plus 3, 1 plus 1, 1 minus 2 squared. So 16 equals a times 4 times 2. 1 minus 2 is negative 1. Any number squared is positive, so 1 squared, or 1, is positive 1. If I multiply the right side out, I get 8a. What's my a value? 2. So I'm going to go right up to the top, and before I put my other factors in, I'm going to put that 2, and that just tells me that the stretch factor is 2. Last equation we're going to work on today is 8-48. Again, they give us this W shape. It goes through 0, it bounces at 2, it goes through 3. They also give us the information that this graph goes through 2.5 comma negative 0.2. Now in the book they're talking about the fact that this is a roller coaster and that the x-intercepts and the x values are talking about hundreds of feet, so this really represents 200 and 300. For our purposes, I'm just going to stick with 2, 3, 2.5, and negative 0.2. 3 parts of this problem that I care about for you guys to know right now. Part D, I'm not really worried about at this time. The first one says, what's the degree? And you should know just by the shape, the W. Remember, 1, 2, 3, 4. So down, up, down, up. That is a 4th degree polynomial at minimum. Okay, and minimum is really what we're looking for here. Roots, what are the roots? Again, roots, zeros, x-intercepts, solutions, all names for the same thing. Well, this graph crosses the x-intercept at 0, it bounces at 2, and it crosses at 3. So the roots are 0, 2, and 3, and the 2, because that's where the bounce is really called a double root. If it would lounge there, we would call it a triple root. Okay? And let's go ahead and find the exact equation. So remember, we're going to start with y equals. The new thing when you see that word exact just means to put an a in front. Okay? It crosses at 0, so I'm just going to put an x. In parentheses, you could put x minus 0. That would be fine. You only need an x here. Then we're going to do an x minus 2 and an x minus 3. Okay? And we're out to find what the a value is. So I'm going to use my ordered pair. Of course, that's my x and that's my y, and just plug it in. Negative 0.2 equals a, that's what we don't know, times 2.5 times 2.5 minus 2 times 2.5 minus 3. So negative 0.2 equals a times 2.5 times 0.5 times negative 0.5. Okay? On my calculator, I'm going to multiply 2.5 times 0.5 times negative 0.5. And I get negative 0.625, and of course I still have my a. I have to divide by negative 0.625 on both sides, and I'm going to get 0.32. So my a value is 0.32. So my exact equation, final exact equation, y equals 0.32 x times x minus 2 times x minus 3. There's my final exact equation.